Hello again. This is going to be Unit 2, Section 2. Looks like there's a typo here. It should be, well, no, this is right. It's going to be Section 1, Part 2. And we have students will be able to manipulate algebraic expressions by identifying and combining like terms with integers that include rational numbers. Please note here that I will be using a lot of different colors here. So things that you might need for these notes are paper, pencil, and calculator, and some colored utensils such as colored pencils, colored crayons, colored pens, anything that has a lot of different colors in it because we'll use that to identify different terms in the problems that we're doing. Our first box asks us to define like terms again, and I hope you're recognizing that since we've asked this, I think 4 times now of you to define like terms, that you understand that this is a very important idea. Like terms are a variable that is exactly the same as another variable, but different by a coefficient. And I'm going to say, but possibly different, because they may actually have the same coefficient. If you're not sure what a coefficient is, this video is going to help you out with that. To combine like terms, the thing that you want to do, let's go and change the color. Let's make this blue. The thing you want to do for combining like terms is combine terms that have the same variable with addition and subtraction, or subtraction. There's a couple ways you can combine like terms, and again, if I'm going too fast, please pause the video. And the methods to combine like terms are you can go up and down, or you can go left and right. The first one that we hear is the first one that we have here is left to right, horizontal. And what I'll do here is I'm going to just group very quickly with colors. I'm going to group different similar terms. The 3 has nothing left here to group. The 3 is all by itself. So I'm going to put the 3 here. The x, the 1x, actually has a negative 5x. So I have a 1x and I have a minus 5x there. And the 8y, the positive 8y, is all by itself. And then what I'm going to do is I'm going to go ahead and simplify this. A 1x minus 5x. Please notice before I actually do that, that this 1 was not here before. So I put it there. So I know how many x's I had. And we get, when we do 1x minus 5x, we get negative 4x. That 3 has nothing to combine with, so that's just a 3 here. That 8y has no other like terms, so that's an 8y. And they're there in complete isolation for the rest of their existence until another term comes along. And the purple box is your answer for combining like terms on this one. For the second one, it's the same exact problem, but I just want to show you that you can combine these vertically too, as in 3. Nothing else here, so that's just a 3. We have a plus x, and the plus x went with a minus 5x. So we have a plus 1x and a minus 5x. And we said we get minus 4x when we do that. And then we also have this 8y, a positive 8y. Nothing else combined there, so we have a positive 8y. And we end up with the exact same answer as before, 3 minus 4x plus 8y. The right side is the vertical side, a top to bottom approach. The left side is a horizontal method. That is a left to right approach, straight across horizontal. Oh, sorry, I'm yawning. It's only 1:34 in the afternoon. Not sure why I'm yawning. Please go ahead and draw a box around the method that you like best. And if you have a different method, go ahead and just describe it below, share it with your teacher because we are curious as to how you're solving these problems. For the next page, we have combined the given algebraic expression for 2 different problems. So let's go and do the first one here. To combine this expression, we need to group our like terms. I have a 9y and a minus 7y. I'm going to do 9y minus 7y. I'm choosing to go the vertical method here. I also look that there is no other y's in this expression, so I'm just left with 2y. For the constants, I have a positive 2 and a plus 12. Positive 2 and a plus 12 together make a positive 14. I also checked that there were no other constants anywhere in this expression. Minus 5x and minus 5x are my x terms, and a minus 5x and a minus 5x are a minus 10x. Nothing that I can combine on the bottom, nothing that I can combine on the top, and this is my answer. For the next one, I'm going to have you please pause the video and try that problem on your own. When you're all done, please press play and go ahead and resume the video. And I hope that you were able to get this answer here. The answer for this one was minus 3x. I combined 4x minus 7x using a horizontal way. I combined minus 2x squared and minus 5x squared because those were different than x's. And I got a minus 7x squared. I had a positive 3 constant all by itself, and this was my answer. I was not able to combine anything else after that because they were not like terms. For the combining your answers from above to get one algebraic expression, let's do this one together. So what I'm going to do is I'm going to combine all my terms together from these. I'm going to combine my 2y and the plus 14 and the minus 10x and the minus 3x and the minus 7x squared and the plus 3. I'm going to see what I get. So 2y looks like it's all by itself, so that's just going to be 2y. A 14, a positive 14, and a positive 3. We'll get a positive 17. A minus 10x and a minus 3x is a minus 13x. Oh, wrong color though. That is the wrong color. Let's try that again. It's a minus 13x. Let's change this color up here. And the minus 7x squared is all by itself because it has nothing else there. Very lonely life for it. I'm sad. And that's my answer when I combine both expressions together. A coefficient is the next thing that we just need to go over here. And I don't remember if I said it already. I don't think I did. A coefficient is the number that comes before a variable. The number in front of the variable is the number that's with the variable. 2 is the coefficient of y. Negative 13 is the coefficient of x. So let's go down to this next part and answer our question here. In the above example, what is the coefficient for the x term? Well, the x term was in blue, and that x term is the coefficient of that x term is a negative 13. And what is the coefficient for the y term? The y term is in red, and the number in front, the coefficient of y is 2. And in the above example was the constant term. A constant term is a number without the variable. That's in green, and that was a green positive 17. If you didn't put the positive sign before, that's totally okay. And you can write any appropriate math joke there. Feel free to share with your classmates or your teacher if it's funny. If it's not funny, you can still share it if you want. And now let's do the last one. Please pause the video and try this one along with these problems at the bottom completely on your own. Good luck. Here's your answer. I chose to go vertical this time. I got negative 4x plus 8y minus 9y. Oh, I forgot a plus sign, plus 9y squared. Whenever you do this method, if you seem like you're missing a sign and the answer is, your result is not negative, but a plus sign. I'm going to write the answer here again so there's not such big spaces there because that's kind of weird for me. Minus 9 plus 9y squared. Okay, and there ain't nothing else that we can do about that. The answers on the bottom are here. Again, a coefficient is a number before the variable or the number with the variable. And then if you chose 1 or 2, please try part 2A for the homework. If you feel like you were pretty confident on this, go to part 2B. All right, guys, thanks for watching.